Good evening, all of you. Today I'm going to discuss about normalization. First of all, I introduce myself. This is Navatha. I'm working as an assistant professor in the Krishna Reddy Engineering College in Department of AML. This is Today I'm going to discuss about normalization. Normalization. It's a topic which is in DBMS database management system. But normalization is a topic in DBMS. First of all, what is the normalization? Normalization. First of all, what is normalization? Normalization, it's a uh, organizing or process of organizing the data in database to avoid redundancy. First of all, what is redundancy? Redundancy is a duplicacy values or inconsistent data. So here, it's a process or technique, the technique to organize the data in database to avoid what data redundancy. Data redundancy in the sense data redundancy. So here we have anomaly. Anomaly in the sense anomaly, we have a problem. Anomaly means anomaly is a problem which is occurs undesirable consequence of data modification. When a data modification occurs, anomaly raises. Anomaly means it's a problem raised when a data modification done. So in place of a table, we have a employee ID and see here employee ID, employee name, employee address, and employee department. For this, we have two rows are the same, but employee department are the different, but we have the duplicacy values. That means inconsistent data. So here we can reduce these data by how? By redundancy, by normalization. So redundancy, what insertion anomaly we have, updation anomaly we have, deletion anomaly we have. For the insertion anomaly, when it will be erases, when we want to insert the data in place of employee name Rick as a some other value, the data. So for that, for second record also, it will be replaced by the other value, but we don't want that. So it's a redundancy problem that while insertion occurs. Update also same problem. If you want to update as a 123 record total row, it will be updated 166. For example, 166. If you want to update fourth row, but it will update as a same in fifth row also. For the deletion problem also, if you want to delete Chennai from the employee address, so it will delete from the 166, that is department, employee department, the Chennai data employee address also, it will be deleted. For that, we have a data redundancy, insertion anomaly, update anomaly, deletion anomaly. Normalization, for it's in simple words, words are normalization. It's a normalization process or a technique to organize the data in database to avoid redundancy or inconsistency of data. So next we're going to discuss about most commonly used normal forms. Most commonly used normal forms are the forms. First is first normal form, second normal form, third normal form, and BCNF form. Fourth normal form, next fifth normal form. Here the normalization. Fifth normalization is for A plus, fourth is A, BCNF is B plus, third is B, second is C, first is normal form. So here, these are the grades. These are the grades which we have taken. So here, Here are the most commonly used normal forms. Normal forms. Fifth is fourth, first BCNF, third, second, normal, first normal form. So here we can use it as a grades wise. Now we are going to discuss about detail about what are the normal forms, first, second, third, fourth, fifth. So what's the first normal form we are going to discuss now? As per the rule of first normal form, an attribute of a table cannot hold multiple values. It should hold only atomic value. That means what? In an attribute or a column, the table cannot hold multiple values. In a attribute or a row or a column, in a column, no multiple values should be there. It should only atomic values. That means single value should be there. So here, example for example, we are having a company wants to store the names and contact details of its employees. It creates a table that look like what? Table employee ID, employee name, and employee address. So here what is the employee mobile? For the 102 record, we have two multiple values, that is mobile numbers, two multiple values. But for the condition is first normal form enti, we have no multiple value should be there in the attribute. So here we have one or two record, we have two mobile numbers. So it's not a normal form. We should consider only single value. That means atomic values. So how it can be? How it can be converted into normal form? To make the table complies with normal form, we should have the data like this. How? Employee ID, for the two mobile numbers, we are having the single values. For the 102, John Kanpur, one mobile number only, John Kanpur, single line and a single value. Single atomic value means single value. The table should contain single values. So the multiple values will be divided into a single value for the first normal form. Now, what are the keys here? Employee ID, determinants, employee name, employee address, and employee mobile. So determinants, employee name, employee address, and employee mobile are the determinants for the employee ID. Now, below table is first normal form. See here, below table is first normal form. That means roll number, name, subject, we are having the attributes. For the 101 record, Acon, OS, CN. CN are the two subjects, that means multi-valued in one record. That means 101 roll number having multiple values in a one row. That means multi-valued. So it is not the first normal form. What will be this output here? First normal form will be the 101 Icon OS for the first row, and the second row will be the 101 Icon and CN. This will be the first normal form. Now next is second normal form. The table is said to be in second normal form if both the following conditions hold. That means the table must be in first normal form. Then next is each attribute must be functionally dependent on the primary key. That means each attribute, whatever we are taking in the table attribute, must be functionally dependent on primary key. Primary key means it should have unique value and also not null. That means each attribute functionally dependent on primary key. That means unique value plus not null. Primary key is unique and not null. So here functional dependency is what? Is a relationship that consists when one attribute uniquely determines another attribute. Functional dependency is what? When one attribute determines another attribute, that will be a functional dependency. If R is a relation with attribute X and Y, R is a relation X and Y. Functional dependency between attribute is represented as X tends to Y. which specifies y is functionally dependent on x. Now here see, non-dependent attributes are removed into smaller subsets. What we have discussed, that is functional dependent, it means primary key. Each attribute must be dependent on primary key. So here which are non-dependent attributes are there, that is converted into smaller subset table. So here second normal form improves data integrity, prevents update insertion and delete anomalies. So by the second normal form, we can prevent update, insert and delete problems. And data will be improves the data integrity. Now see here, employee name, employee address are functionally dependent on employee ID, as you know, which is primary key. So here for the employee mobile, which is not functionally dependent on employee ID, is divided into subset. We can guess easily that employee name and address can be dependent on ID, but mobile number cannot be dependent on not functionally dependent on other employee ID. So we can divide this table into subset of the table. That means whatever it is there in no, it should be fully functionally dependent, it should not like act as a partially dependent. For example, A, B is having a person's partners dealing with the other who is a client. Only a B person as a partner is meeting with the C person, who is client. It's a partially dependent. That's why it's not considered as a second normal form. Next is candidate keys. What are the candidate keys in here? Employee ID, employee name, address are the candidate keys. What are the candidate keys? Actually, candidate keys is unique values. Whatever we can take it as, it can accept the null values. But primary key is what? It cannot accept the null value. The main concept of the primary key is it should be compulsory unique value plus not null. That's a candidate key and a primary key. Now comes to non-prime attribute. Non-prime attribute means not another unique value. So employee number. It can have employee mobile can have a number of employee mobiles. So more than one mobile numbers also can have for one person. So it's a non-prime attribute. An attribute that is not part of a candidate key is known as a non-prime attribute. So see here, not part of a candidate key means candidate key is what here? Employee ID, name, address are the candidate's key. So employee mobile, we are not considering it as a considering it as a not functionally dependent on employee. So we are taking it as a non-prime attribute. Now, is below table is second normal form? No, because see here, teacher cannot be dependent on ID, subject ID, score ID. So here, score ID, student ID, subject ID, mark can be in one table. Based on subject, teacher also will have a table. Now comes to third normal form. Table is said to be second normal form if both the following conditions hold. That means what? It should be compulsory a second normal form. Then next is there is no transitive functional dependency. There is no transitive functional dependency. Transitivity dependency is what? X tends to Y, Y tends to Z becomes a X tends to Z. No transitive functional dependency means here see, when a non-prime attribute depends on other non-prime attribute rather than depending upon the prime attributes or primary key. Whenever the non-unique or non-prime attribute depends on non-prime or non-attribute rather than clever or unique prime attribute. That means, for example, we are taking three persons. A is non-prime attribute, that is A is prime attribute, that is unique value. B is non-prime attribute, non-unique value. C is also non-prime attribute, non-unique value. A is telling to B that I will be helpful in exam, don't worry. Who is non-prime attribute. So B is also telling that I will be help for the exam for C, who is non-prime attribute. B non-prime, C non-prime, but A is prime. A is prime, that is unique value. He can help to non-prime, but non-prime attribute does not cannot be helpful to non-prime. So here is a condition. Non-prime attribute depends on other prime attribute rather than depending on prime attributes. So functional dependency is said to be transitive if it is indirectly formed by two functional dependencies indirectly formed. So see here, for example, x tends to z is a transitive dependency if the following three functional dependencies holds true. X tends to z is functional dependencies hold true because x tends to y, but y does not tends to x equal to x tends to y. X can be determines to y, but y cannot be determines to z. So x tends to z will be a transitive dependency. Now here see here, employee ID, employee name, department ID, department name will be the determines employee name. Here see, employee ID, name, employee ID, employee name determines department ID, and department ID determines department name. So therefore, employee ID determines department name, department ID, and we have transitive functional dependency, and if this structure does not satisfy the third normal form. So remove the attributes which are dependent on non-key attribute from the original relation, which are dependent on a non-key attribute. That means, see here, creation of a new table, non-key attribute which is determined in the transitive dependency. Employee ID, name, department will be the employee table, department table, department ID, department name. Here is this below table third normal form? No. Why? Because it's a non-key attribute can be divided into other table. Now see here, next is BCNF. BCNF means boys code normal form. Boys code normal form. It's an advanced version of third normal form. That's why it is also referred to as 3.5 normal form. We can say it as a 3.5 normal form. For example, that's why we are saying it as referred to as 3.5 normal form. For example, see here, employee ID, employee nationality, employee department, department type, department number, employee is the attributes for the table. It should be compulsory. Second, third normal form should be there. For every functional dependency, x tends to y, x should be the super key of the table. Whatever there in the x table, left hand side must and should super key of the table. See here, super key of the table should be the BCNF form. Next is functional dependency in the table are employee ID determines employee nationality. Then employee department determines department name, department type, and department number. Next is here, see here, candidate key, employee ID, employee department consider as a candidate keys. The table is not in BCNF as neither employee ID nor employee department alone are keys, because it is not considered as a BCNF because it is employee ID nor employee department alone are keys. We are saying it is a To make that table comply with BCNF, we can break the table into 3 different forms. Before, this is not the BCNF, so we are dividing this table into new, that is 3 tables that we can, first table is employee nationality table that we relate to the ID and nationality, and next table is employee department mapping table. Employee department mapping table, that means employee department mapping table. Next is employee department table. Now, left hand side, whatever there in the left hand side, it is considered as a super key. What is the condition for the BCNF? The left hand side which is there in the table not transitive dependency, whatever there extends to Y or whatever there in the left hand side, that should be the super key. See here condition, what is that? For every functional dependency extends to Y, X should be the super key of the table. What is in the left hand side, that must should be the super key. Here it is a condition and table here. Next is we are having the table that is author, nationality, book title, genre, number of pages. So here we are having the attributes. What are the author, nationality, book title, genre, number of pages. And William Shakespeare, Marcus Wiener, Jeffrey Ullman, Jennifer Wisdom, English, Australia, American. So book titles are this, genre and number of pages. So how it will be related to 3 tables? BCNF, for the BCNF, it should be the compulsory, what left hand should be the what super key. So candidate key or the super key. These are the, for the left hand side, what are the candidate keys? Super key, William Shakespeare, and author is a candidate key. Now here it is, the book title is a candidate super key, and here also candidate key, author also candidate. For the previous table, how can we divide it into 3 tables? Now next is fourth normal form. Fourth normal form, first, it eliminates independent many-to-one relationships between columns. Between columns means fourth normal form eliminates independent. What are the independent many-to-one relationships between columns? Many-to-one. As we all know, one-to-one, one-to-many, many-to-one. Here it is saying that eliminates independent many-to-one relationship between columns. A relation must be in BCNF. The rule for the fourth normal form is, what are they? It must be BCNF, and it should not have any multi-value dependency. And what will eliminate? Independent many-to-one relationship between the columns. Independent. See here. A table is said to be multi-value dependency if the following conditions are true. Here for the dependency A to B, for a single value of A, multiple values of B. Here see, for a single value of record, we are having a multiple values. Then the table may have multi-value dependency. So we are taking it as a condition that table, that is student ID, course and hobby. Now the given student table is in third normal form, but the course and hobby are 2 independent entities. See here. The rule is what? It must be BCNF. So here it is it satisfied the condition, that is it is in BCNF. It is in third normal form. But the course and hobby are 2 independent entities. Condition for the fourth normal form is what? No, not have any multi-value dependency. Should not have any multi-value dependency. So here, course and the hobby are 2 independent entities. Then, hence there is no relationship between course and hobby. So we are that so to make the above table into fourth normal form, we can decompose into two tables. So student course, student hobby. Now these are the two tables which we divided from the previous table, that is student ID, course, hobby. These are the tables. Next is example. For the another example is bike model, manufacturer, year, color are the attributes of the table. Now for the fourth normal form, what should be there? No independent values. So bike model, manufacturer, year will be the one more form. A database is said to be in fifth normal form if and only if it is in fourth normal form. That means it must be in a fourth normal form. Now the next rule is if we can decompose table further to eliminate redundancy and anomaly. If we want to reduce the table or decompose the table to eliminate redundancy or anomaly, to overcome the anomaly or redundancy, we are decomposing the table to the table from the main table. So here what is saying here, when we rejoin the decomposed tables by means of candidate keys, we should not be losing the original data or any record set should not arise. Here what is saying that when we rejoin the decomposed tables by means of candidate keys, whenever we are dividing the table from the main table to the sub tables, it means of candidate keys. We should not losing the original data while dividing. When we divide the table and rejoining the table, while rejoining the table, the data should not be lost as the original data, or a new record set should not arise. Any new record should not be there for the joining of the table. In simple words, joining two or more decomposed tables should not lose records or nor create new records. When we join the two or more decomposed tables, when more than one table, if first of all, we are decomposed to redundancy because of redundancy and anomaly. If we want to rejoin that decomposed table, that should not lose the record and create new records, nor create new records. Here subject, lecture, class is a attributes. Next, maths, and these are the subjects: maths, physics, chemistry. Who are the lecturers? Alex, Rose, Joseph, Adam. Classes are what? Sem 1, Sem 2 are the classes. Now we can represent each lecturer's subjects area and their class in a better way. How? We can divide the above table into three forms. How can we divide that? Subject to lecture, lecture to class, and subject to class. These are the tables we can divide it from the main table. That should be a fifth normal form. We are taking it as a T3, class as a T3, subject as a subject select T3 dot class, T3 dot subject, T1 as lecturer. Now from tables, table 3 T3, table 3 T2, table 3 T1. We are semester 1 and T3 subject equal to physics and T3 subject equal to T1 dot subject. It is a very how we can reduce it, get the data from joining. So here are the three tables we can decompose from this subject and rejoin from this query without losing the data and without new record. Now we can divide this table into three tables: agent, company, product. R1 we are taking it as an agent company, R2 as an agent product, R3 as company product. Now stages and actions, how we perform. Stages are what? Now see here, stages of normalization. Stages of normalization, here are the stages, here are the actions. To overcome the redundancy or to become the redundancy or inconsistent data, on stages of normalized relation. First normal form, second normal form, third normal form, bichord normal form, Boyce chord normal form, fourth normal form, fifth normal form. These are the stages of normalization for the normal forms and the actions to be performed between the normal forms. Unnormalized relation to the first normal form and first normal form to the second normal form. What is the removing? Repeating groups. For the first to the second, what is how we remove partial dependencies. Then second to third, remove transitive group. Then third to Boyce chord normal form, remove functional dependencies. Now Boyce chord normal form to fourth normal form, remove multi-value. Fourth to fifth, remove remaining anomalies. These are the stages we perform for the normal forms and actions to be performed. Next is employee ID, employee name, employee department ID, department name, and employee. For this, how we can normalize the table through normal forms. Thank you for the session.